Hello guys, welcome to my channel. So in this video I am going to explain about a very important feature of Java 21, that is virtual threads. So actually if you have ever heard that Java can now handle millions of concurrent tasks with very little memory, then this is the feature, that is virtual threads, which is making it possible. So in this video we are going to understand about what are virtual threads, why Java introduced virtual threads, and what are the difference between platform threads and virtual threads, how do we create virtual threads, real world examples and interview questions. So let's get started. This is going to be a fun video. So why were virtual threads introduced? Suppose first we will try to understand why this concept virtual threads was introduced. Suppose you are building an online shopping website, okay, some e-commerce website you are trying to build. 1,000 users visit your website. So for each user, that means each request you are creating one thread. And if there are 1,000 users, you are creating 1,000 threads. Okay. So this is a normal thing. Creating 1,000 threads is not a big deal. So imagine if 1 lakh users visit your website, and if they send 1 lakh request, so you need to create 1 lakh threads. Okay. So that is the problem, because creating 1 lakh threads is not easy, because each thread consumes some memory and each thread is managed by your operating system directly. Okay. So creating thousands of operating system threads become very expensive, because it consumes CPU memory, processing power, everything will be consumed and your system will become slow. So that is the problem we are facing. And we try to understand about platform threads. What are platform threads? Basically, platform threads are nothing but these are the traditional threads. So how we are creating a thread? We will be using thread is equal to new thread, and after that the task will be running it in the form of lambda expression and thread dot start. Okay. So one Java thread you are creating in the its above example. So one Java thread is equal to one OS thread. That is because every thread is managed by operating system. Okay. And every thread consumes some memory, the stack, and thousands of overhead and scheduling overhead. And if you create thousands of threads, that is Java threads, it will create thousands of operating system threads, and there will be a performance issue. So in order to overcome this situation, they introduced a concept called as virtual threads. So we are going to virtual threads. So this is the concept they introduced. So what happens is, for one request we are creating one Java thread. So one Java thread is equal to one OS thread. Okay. But here in virtual threads, even if you are creating 1,000 virtual threads, for example, you are getting 1,000 requests, you created 1,000 virtual threads, that 1,000 virtual threads is equal to only few platform threads. That means, for example, assume I will giving you an example. Here there are 1,000 virtual threads. That means it is equal to 500 platform threads. That means that is equal to 500 operating system threads. So you instead of creating 1,000 threads, you are reducing it to 500 threads. That means 50% reduction in thread creation, that improves the performance. Okay. And you know that these Java threads, okay, these platform threads are managed by your operating system, but these virtual threads are managed by your JVM instead of the operating systems, because of which we call it as virtual threads, and they are lightweight. That is why we are able to create millions of virtual threads, because they are not directly related to operating system. Because virtual threads, if you create many 1 lakh virtual threads, it may be a few platform threads. Okay. And now let's try to create, how do we create virtual threads basically. So there are two ways to create a virtual threads. So you can see this is the code. So I'll go to the IDE and I'll show. So first one is thread dot start virtual thread. Okay. So how do we create? Means the simple thing, you thread dot start, there is one method called start virtual thread, and it is taking a runnable task. Okay. So that runnable we are giving it in the form of this lambda expression. This is run method, so we are giving it in the form of lambda expression. Okay. This is one way of creating a virtual thread. This is the first way. And the second way is using thread dot off virtual method. Okay, we have one method called as off virtual. So with this method you are trying to create a thread. So and this off virtual method will return is the thread dot builder. And whenever you want to start a thread, that means to create a thread, you will be calling thread dot start method. Here no need to call, because it will be called automatically. Here we are calling start method, and you will be creating the thread. So this is one more way. So now let's try to debug the first way. So I'll try to run this code and check whether the virtual thread is getting printed or not. Oh my god. See, there is no output. You are not getting the output. Okay. So you will think that, bro, you have not started the thread. First, you start the thread, then you will be getting the output. Okay, I'll try to start the thread. So when I try to start the thread, you will be getting a exception. So I'll show you the exception. See, I told you, right? Illegal thread state exception, because so when you use thread.start virtual thread, you are already starting the virtual thread. You no need to start the uh, thread again. So why you are getting this thread state exception means, because in the multi-threading concept I have explained you, if you try to start a thread again, terminate a thread again, you will be getting a illegal thread state exception. That is what you are getting. Then why we are not getting the output? That is the question, right? So what happens here is, so this start virtual thread, this method is there, this is a daemon thread. Okay, so this main thread, because the main thread is the responsible for executing this main method is, so this main thread will finish us off immediately, and it will shut down the JVM, and it will not allow this virtual thread to run and execute. So that is why before this virtual thread executes, so the JVM is getting shutting down. So because of that, you are not printing the output. Then what is the solution? So what is the solution means, I'll try to catch it in a variable. Then I will tell main thread, hey main thread, you have to wait until I complete using thread.join method. So I am telling then I need to throw some exception. I am adding it to the method signature. I am telling the main thread, a main thread, you need to wait until I complete my execution. Now, if I try to execute the method, oh my god, you are getting the output. See, you got the output as hello. This is one method. And also, you can use the thread.sleep as well. So, instead of this, you can use thread.sleep. Let me use thread dot sleep. I'll give you some 2 seconds, okay, and I'll try to run. Even in this case also you will get the output, but I think this is the recommended way is the first method, that is thread.join. You got the clarity, right? So now we created the virtual threads, and we have successfully got the output from the virtual threads. Now let's look at the difference between the platform threads and the virtual threads. Okay, so these platform threads are there; those threads are heavy. These virtual threads are lightweight. We all know that. And these platform threads are managed by your operating system. They are directly related to your operating system, and virtual threads are managed by your JVM. And platform threads limited. You can create only limited number of platform threads, and virtual threads you can create millions of possible. I'll show you how we can create millions of virtual threads. And creating a platform thread is expensive, because each platform thread is associated to operating system, which includes memory and processing power. And virtual threads are cheap. And platform threads, more memory is required, because they are obviously associated with the operating system. And virtual threads, they have less memory. Now let's look at some real world example. So I am going to explain this example very clearly. So imagine you have a food delivery app, and 10,000 users orders the food simultaneously. In that case, 10,000 threads has to be created. Okay, each request will create one thread. So 10,000 threads are created. So every thread will be doing like it is checking the restaurant, checking the payment, calling the database, calling another API. So these operations are mostly waiting operation, that is time waiting operations. So if you are using a traditional thread like that platform thread, what happens is, whenever you get the request, all the threads will be waiting, because some will be checking the restaurant, some will be checking the payment, some will be calling the database and all, and threads remain blocked, and user spends more time in waiting. Okay, so if you use the virtual threads, you will send the request. Okay, and then instead of platform threads, we will be using virtual threads. These virtual threads will be responsible to handle these tasks like checking restaurant, payment, database and all. And this platform thread what you have, it can serve another request. Okay, with this what you are getting is, you are getting the better scalability without changing your business logic. With the same business logic, same thing, just by using the virtual threads, you are getting better scalability and also better performance. So that is the magic that you are doing with the help of virtual threads. When you should use virtual threads, so this is the next concept, guys. So when you should use virtual threads, virtual threads you should be using, it is great for REST APIs, Spring Boot, database operations, file operations, network calls, microservices, Kafka, consumers, HTTP clients, because these are the these are the tasks that spends most of the time in waiting for input output operations. So in this case you should use the virtual threads. Okay, and when you should not use virtual threads means heavy CPU related calculations, like for example it requires complex arithmetic, algebraic, mathematical calculations. In that case you cannot use virtual threads. And image processing, video rendering, machine learning computations, so these are all for all these activities you cannot use the virtual threads. Okay, so what what is the concept is, I have seen many YouTube videos where they are telling virtual threads are faster than platform threads. So that is not the actual thing. So virtual threads, what it will do means, it will not make your CPU faster, but they improve the scalability for the task that spends the time in waiting. Okay, because if you create most of the platform threads will be on waiting status, means they won't take the other request, and the user will have a very bad experience. For example, you created only 1,000 threads, like maximum threads you have created 1,000, and 1,000 requests came, and these 1,000 threads are busy in processing those requests only. And if another user tries to access your application, he will be in loading status, that is waiting. So that is a bad user experience. So with the use of this virtual threads, what you can do is, you can hand over this wait consume this is time waiting task to the virtual threads, and so that you can go and take the other request. So that is the use of virtual threads, that will make your application responsiveness, performance, everything will be improved. Okay, so I'll before moving to interview questions, I'll show you how do we create virtual threads. So you can see this demo. So first I'll comment this code, because uh, I am manually trying to create 1 lakh threads. Okay, so you can see I have a for loop. I am creating 1 lakh threads. How I am creating? Not virtual threads. I am creating the platform thread, new thread. I am printing thread.current thread and start. Okay, you can see how much time it will take to create these 1 lakh threads. I'll run the code. Oh my, wait. No. So okay, let me run the code. Yes, see, you can see it will be click, it is running, it is creating 6,000, 7,000, 8,000 threads, 10,000, 12,000. You can see how much time it will take in order to create the 1 lakh threads. I will keep this program running so that you can see visually how these programs are running. Yeah, it's running 35,000, 36,000, and for every thread it is consuming the CPU, memory, processing power, resources are getting wasted, guys. Listen to 50,000 threads. See, it's still going on. I think if I try to create 10 lakh threads means definitely I used to get exception. But I think as far as my CPU power and utilization, it will create 1 lakh threads. You see how much time it is taking. It's I think more than 20-30 seconds it is taking. Still 80,000 threads are created. Come on, buddy. 90,000. We reached 90,000 threads, guys. 95. Finally, it created 1 lakh threads. Oh my god. Yes. Finally, it created 99,000. So, you can see, finally, it created 1 lakh threads. You see how much time it took, almost some 20 to 30 seconds it took in order to create, because these are created by operating system platform threads. Okay, now what I will do means I'll try to create this virtual threads. You can see, just I'll run this code. Okay, you just see how much time it will create. I am also creating 1 lakh threads here as well. I am using the thread.start virtual thread, and boom, let's start this code. You can see done guys. See, done. 1 lakh threads it created. You see, I am not showing. See, you can see I'll go up. See, worker 1, worker 2, worker 1 lakh threads got created within a just a blink of an eye. So that is the power of virtual threads, guys. You know that, right? How these virtual threads are getting created. Now let's look at some of the interview questions. So what are virtual threads? These are the lightweight threads which are managed by the JVM. And are virtual threads faster? So they are not necessarily faster, but they improve the scalability, not the raw computational speed. That means it will improve the scalability of the task that spend most of their time in waiting. Okay. Can I create millions of virtual threads? Obviously, this is one of the biggest advantages. I showed you, right? I created 1 lakh threads, and within a blink of an eye, all those threads got created. Are virtual threads good for Spring Boot? Definitely, guys, definitely. Because Spring Boot means we have so many operations, blocking input output operations like database calls, REST API calls, messaging queues. So many things are there. Definitely, you need to use virtual threads for your Spring Boot applications. And before Java 21, that is before this virtual threads concept was introduced, if there are 1,000 requests, then I have to create 1,000 platform threads, and all those are managed by operating system. But here, if there are 1,000 requests, I'll be creating 1,000 virtual threads, but very few platform threads which are managed by this operating system. See the difference. Okay, here for 1,000 requests, 1,000 platform threads. Here for 1,000 requests, we are creating few platform threads. That means any which are less than 1,000 platform threads. So that is more than enough. So I think you have clearly understood the concept of virtual threads. If you have any doubts, please type it in the comment section, and thank you so much for watching, guys.